Science is not just a study of a tiny thing in just your expertise. Science is about everything, understanding all the mechanisms that are interplaying.
CAASTRO enables people spread all over Australia who have similar interests to join into a team to tackle a problem that can't be done at one institute or by one person.
The problems we're trying to solve are more detailed and therefore more complicated, and you therefore need a lot of different views on this, and CAASTRO is a great way of bringing all those minds together.
It's changed the whole culture of astronomy. It's made doing things in a collaborative way, doing things in a cultural way, the way that Australian astrophysics now works.
CAASTRO has three broad themes. We're looking at questions related to the dark universe, so dark matter and dark energy, what's their physical nature. There's the transient universe, so there's things that change in the universe on quite short timescales. And then the part of CAASTRO that my own personal research is in the evolving universe. And here we're looking at what a galaxy looks like and how it changes its appearance over these past billions of years of cosmic time that we can observe with these new telescopes.
The evolving theme in CAASTRO is actually the largest theme. It's the largest because it encompasses a large range in cosmic time.
When CAASTRO first began, we had a new low-frequency radio telescope, the Murchison Wide Field Array.
MWI has been enormously successful, so successful in fact that CAASTRO has helped lead an expansion of MWI. The other instrument we've been heavily involved in is the ASCAP array. CAASTRO has been one of the lead centres in using early data from that facility to again understand galaxies over a range of cosmic time.
SEM is actually part of the evolving theme within CAASTRO. It allows us to get spectra at every point over the face of a galaxy in quite a lot of detail. With SAMI we've got those 3D data cubes where we know how things are moving, how they form, what they're made of, and the simulations are able to provide us with equivalent things for theoretical mock universes, and so we can actually bang the two things together. We can confront the data with the simulations and learn something about both of them.
The dynamic theme is split in halves. There's what we call the slow transients and fast transients.
So these transients can tell us about how the sky changes, on what time scale does the universe change, and by observing the changes you can understand the physics that's behind those changes.
One of the big advances of CAASTRO was the detection and the discovery of fast radio bursts by the Parkes Radio Telescope. So this now introduced an entire new research field into understanding what's inside of our universe by being able to see these fast radio bursts.
Conducting these surveys produces enormous amounts of data. So there's been a lot of innovations in terms of software. How do we store that data? How do we transport it? How do we analyse it? And then how do we find the rare objects?
Within the dark theme, we had a wide range of different types of measurements that together allowed us to constrain the types of models of what dark energy and dark matter could be. With a survey called WIGGLES, we measured almost 250,000 galaxies and mapped their positions. One of the other great successes with CAASTRO is AusDES. AusDES is the Australian Dark Energy Survey.
With the Dark Energy Survey, we're coming up to being able to release data from the first 3 years of DES.
The survey that had to find the Type 1a supernova at low redshift was SkyMapper. We have right now 35 Type 1a supernova confirmed from SkyMapper.
We, with CAASTRO, did two peculiar velocity surveys. One was called 60F, the other was 2MTF, and together they gave us a map of the motion of galaxies in the universe.
We've been very blessed in that the Dark Universe discoverer became the Vice-Chancellor of our most prestigious university. The evolving theme has evolved into Astro 3D, which is sort of a successor to CAASTRO, and OSGRAV is a natural consequence of the dynamic theme.
This won't disappear, this momentum within the community, the collaborations that we've built, these now exist, and the 7 years is long enough to really propel them forward.
People look to CAASTRO and see something that's been very successful, and they see that that's based not only on careful organisation and use of money to do particular research programs, but also to this broader base of changing the culture and the way that we do research. And I think that impact is the really long-term legacy of CAASTRO.